Thanks, Matt. Everyone can hear me okay in the back? Good deal. Happy Star Trek Day, right? Awesome. I wait for this day every year and excited to be here on Revenge of the 5th. I don't know if you knew that, kind of after May the 4th. But I know you have a lot of choices. There's a lot of other speakers and sessions going on. Let me be the first to say you picked wisely. This is a good one. So who am I? I'm Heath Murphy. I'm a director for CGI. We have a booth out there. Quick plug, if you've not been, we have t-shirts. If you want to listen to me talk about our company and the cool things we're doing here in Columbus, fine. Let's be honest. If you just want the t-shirt, I'll give you one. That's okay. The sleep code t-shirts. Being a director means I don't get to write code much these days for work, so nights, weekends, that's what I do. Being from Columbus means I'm a Buckeye fan. I bleed scarlet and gray. I think it's actually written into law somewhere. So, yeah. OH? There we go. This was my COVID hair. So, can you believe it? This is not fake. I know a few of you here in the room know me. That's legit, like real blonde hair. So, and I'm sure you have a COVID story as well. We all have our COVID stories. So, that was mine. Let it grow out. And I have an unhealthy fascination for pumpkin ales. It's weird. I have an Excel spreadsheet, being a developer architect, where I'll go and track this. I'm up to about 120. I would do more. I just can't get more here in Ohio. So when I go out to other states, I try different pumpkin ales. But when those aren't in season, any unhealthy IPA I can get. So Creeper is kind of my go-to if you're here in Columbus. So we got a full agenda here. We're going to be talking about microservices, and not just the plain old what they are. This is my story. This is from the trenches, battle scars, war wounds. I've been burned a lot of times. What have I learned? What can I share with you? How can you pick up from my mistakes here? So we'll do a quick level set on microservices, what I mean by microservices, but not much. We'll jump into correlated logging, monitoring, eventual consistency, self-healing patterns, and then expect the unexpected, which I'm not sure how you do that, but we'll have a plan. So I'll start with a brief project rundown. So this is a real project that we worked on here for one of our clients. I won't name the name of the client, but project took many years to build. As you find with these giant microservice systems, it takes many years, but it's there. It's actually still running today, and I'm proud of what we built there. And so the whole talk is all about this architecture of what we built. So let's jump in. It's an order fulfillment system for a US-based specialty retailer. So think of e-com system with a facility that does pick, pack, and shipping. So they've got 1,200 brick and mortar stores. They've got 15 plus e-com websites. Some of these are branded to the store. Other of these websites are standalone pure play e-com websites. And then add on to that a bunch of B2B partners that want to sell on their platform or do fulfillment orders through their own website. So you can see there's a lot of players here, a lot of things coming in to this microservices area with all the exclamation points. And then to do things like payment capture, order management, pick, pack, ship. Ultimately, it gets sent out to a customer, a store, or a series of stores. So a little bit about the overview here. You'll hear me use the term fulfillment and order. They're technically two separate things, but they start out as a fulfillment request. So someone purchases on a website a set amount of product. It goes through, there's validation that takes place, stock reservations, warehouse submission gets sent, and then ultimately it gets picked, packed, and shipped. So the system itself has lots of files. We're ingesting EDI files, flat files, you name the type of file, it's probably coming into this system. API REST calls, message queues, phone calls even are in, manual entry into the system. Essentially the mantra was, we want your business, we'll work with you. How do you want to work? Okay, we can do that. It's not my mom calling. That's happened before, actually. So you also hear me say a business event. So when I say the word business event, these are interesting events that occur in your application. So some examples are, update requests, cancellation requests, verification for a prescription. The specialty part of the retailer is eyewear, contact lenses and eyeglasses. So these are the interesting business events that occur in the system, and just an example of some of what we have here for the system. If you haven't figured it out yet, e-com is complicated. You shop at Amazon, I'm sure all of you do. I shop way too much, spend way too much money. But when you think about placing an order, it seems simple. You search for an order, find what you want, read some reviews, but you've got a lot of things happen on the back end, and the system had to take that into consideration. You've got sales tax, which is extremely complicated. You've got what do you do when you don't have inventory? You need to reorder. Well, how much do you reorder? How much do you keep in stock? You don't want to keep too much in stock. You need to keep just enough in stock, but you don't want to piss off your customers. So returns. Customers like to return things. So the system here needed to be able to handle merchandise returns and how those get back into stock. Inventory management, customer service, and then ultimately shipping providers. I need to ship a box. Is it cheaper to use FedEx versus UPS versus USPS? And how much product can I fit in that box? So this system we built here manages all of this. So as you can imagine, it's pretty complex, and there's a lot that goes along with e-com that you probably don't think through when you place your order on Amazon or any other website. So quick level set on microservices. So when I say microservices, I don't mean Docker. And the funny story is I've been in this software development thing for over 20 years. I can say that now. It's been quite a long time. But back when microservices first came out, it was synonymous with Docker, and just throw your code in a Docker container, check mark, you've now got a microservice. Not true. Not true. I promise you. So let's level set. What do I mean here, and how does it pertain to this talk? This is directly from Wikipedia. I didn't write this. I copied it in here. But a couple things. I think it's important. So as you can see up there, there is no single definition, of course. It's technology agnostic. It's built around business capabilities and what fits best. I think that's an important thing. There is this red section here. This is the only thing on the entire deck that I'll read directly because I like this. So services are small in size, message enabled, bounded by context, autonomously developed, independently deployable, decentralized, built and released with automated processes. That's a mouthful. But to me, looking through this, that kind of sums up what we're talking about when we say the term microservices. And of course, platform agnostic, all the things. So going back to the example here with the e-com platform, what did our service look like? What did this architecture look like? And you'll see we broke rule number one. One database to rule them all. What you'll find when you embark on any of these sort of big projects, especially if you're a consultant working with a client, is the client wins. And in this case, they love their SQL Server. They loved having millions of tables in there, being able to slice and dice the data. So taking that database and right-fitting it inside of microservice wasn't going to happen. So unfortunately, this system didn't have that, but it didn't stop us. We still built an awesome system. All the things .NET, so C#. Everything I have here that I'm showing you is done in C#. It doesn't have to be done in C#. There's no code in any of these slides, but they are .NET shop, and when Microsoft releases it, they're on it the next day, which is kind of cool if you're a .NET developer. Messaging, extremely important part of any microservice. If you're not using any sort of messaging service bus system, you need to be. We leveraged RabbitMQ, and as you'll find, a lot of the patterns are built around leveraging some sort of message queue. Rabbit works fine. I like Rabbit. And off-the-shelf product, I know we're developers. We like to write code for things, but it's okay, I promise. The tool we used here was for processing EDI files, and it's probably a little blurry up there on the screen there, but if you've never dealt with an EDI file, good. Run. Fixed length, it's not fun. So get a tool for that, and we did. So I marked out the names here because it started out as a tool called RSS Bus, and then it got acquired by ArcESP, and then actually I think it got acquired again. So it seems like every 6 months to a year, this product gets rebranded and renamed, but it did the job. It ticked the box and handled these files for us, so we didn't have to do it in .NET. And bonus, we're going to talk about Elasticsearch. So I bet you wasn't expecting that. It's one of my faves, actually. Okay, what did we miss? So we talked about microservices. I mentioned kind of what we built there, high level. no cloud at all. This is all on-prem. No containers. We already established you don't have to have Docker to be considered a microservice. No MongoDB. Like, why? What do you mean by MongoDB? Again, going back, grizzled old Heath, 20 years experience. It seemed like containers, and then you've got, doesn't have to be a SQL server. A .NET developer can build a microservice and not use SQL Server. We're going to use Mongo. So Mongo and it all got jammed up in here and got synonymous with microservices. No MongoDB. And you know what? We created an awesome system. An awesome system that's still being used and still works as expected. Is this better? All right. So let's start with correlated logging and monitoring because logging is so fun, right? Let's start with the fun stuff. We start by activating logging greatness. I know, it's great. But joking aside, you got to get this right. These are the foundation pieces. You need to get logging, monitoring in place before you write your first microservice. Because I promise you, you'll need that to write your microservice as you get through this process and take this journey. So pick a package. I don't care what it is. We use Serilog, but find a package, use that, build a template. That way developers aren't using their own templates for logging, and make sure you check that in PRs. So make sure that's being there. Happy path logging. Everyone does try, catch, exception, log. Of course everyone does that. But are you putting info logs in there? Important info logs and logging information that might be helpful, such as the inbound message and other items, because you should be. Correlated logging. So correlation ID, show of hands. Who's heard of correlation IDs? Okay, seems about half. Okay, so require these things. Every service you build should have a check to make sure, okay, do I get a correlation ID? If not, reject it. Build that into your system. More on that later. And then aggregator platform. You're going to have logs from everywhere. Info logs, exception logs, error logs, you name it, it's going to be there. You need some sort of aggregator platform to be able to search these things and make sense of them. So example, monolith app. This is all in process, no web APIs, no services. So they all call each other, and you get beautiful logs. They come out looking like this. It's easy to reason through. I can read through that, makes sense. What happens when you get a microservices architecture? You've got this thing broken out, you've got different databases, you've got potentially pulling from a queue, you've got services calling other services, which is an anti-pattern we'll cover. You've got logs happening everywhere, dozens of logs. So you don't get that nice, pretty look of a log file that you can just download and kind of reason through. You're going to have these things asynchronous, maybe coming. They're going to be all over the place. So this is where an aggregator platform is going to help you. Let's come back to correlated and key logs. So correlation ID is an industry term. It's been out there for a long time. Key logs is something I made up, and I think it's important. So let's start with correlation ID. So when you have a business transaction, so I've got a fulfillment request that comes in. I need to do some basic validation. I need to check stock. So whatever your business transaction is, it's going to span multiple microservices. You're going to have 2 or 3 microservice calls. It may set in 1 or 2 queues. It's a process. It spans a lot. So you need to create a correlation ID at the head end system. And head end can mean different things for different people. But in our case here, it was the one fulfillment API. That's the entry point into this business process. Take that correlation ID, create it. We created it using GUIDs. Worked for us. And then pass that along to every single microservice in your business transaction. How do you pass it? We use the header, worked for us, so you can see up there, just pass it in the header and then do assertions on that for downstream systems. And I'll show you how that shows up and why that's important in another slide here. Cross-reference log keys. Again, I made this up. It's a term I have here, but your business and your IT staff, and likely you don't talk in correlation IDs. You don't go search logs and say, oh, I got a correlation ID, I'm going to go search for it. You may if you're an odd person, but you know things like order number. Your business knows things like order number. They know warehouse order number. They know customer ID, customer email. These are all things that have meaning to them. So what you do is when you get a message in, you've already got your correlation ID. this message likely has some sort of identifier, whether it's an external identifier from a trading partner or an internal identifier that shows up on a screen somewhere for the call center. Take that and store it in a basic table where you can do a mapping. And then when you get another one in for the same correlation ID, update your mapping. So over time, you're building this catalog of, okay, this order number here is really this external partner number is really this customer ID. So you're stitching it all together. And you're like, why, Heath? Why would I do that? You do that so you get something like this. This is what we built. Having to do this all over again, I'd probably pick a tool off the shelf to do this and not handwrite this, but we did. Of course, we're developers. We can write code, and that's what we did. But how this works is you've got a search box up there. You put in any of those external numbers. Doesn't matter what it is. You got the screen up, and you're looking at it. You got a customer ID, throw it in there. If you got an exception from a bug in your version control or whatever that came through, throw that in there. And what you'll see here is that these are all business transactions. So since we've tied it to a correlation ID, you see this correlation ID went through multiple microservices. Each one of those did some info logging. And then there was a pause, something happened. And then down here is a separate business transaction that also impacted that same product in this case. So you get a nice little audit history trail where you can go through, and it makes debugging your code and understanding the overall finished system a breeze. And always log the inbound messages and errors, of course. So you can see clicking that pops up. I'll come back to the retry because that's important. And not only that, let's take it one step further. So you built this nice aggregator tool. Now you can understand kind of how all these business transactions are cross-cutting all of your microservices. Give it to the business, because we did. We gave this to the business, and they were so happy about it. You could just see the smiles. They didn't have to come to IT to wonder where this order is or why it's stuck, and that's not really the business. That's an image I found somewhere, but we really did, and they're using it today. So enough on logging. Let's move to something slightly more interesting here in monitoring. So monitor everything. Anything you can possibly put a monitor on, do it. So bare minimum, have a health check on every single API you build. Moreover, just call it health check. Don't be creative with names. Don't try to have different names. Just put /health check in the route. Call that your health check. And check things like connectivity and basics. True story, little side story here. Had a developer on one of my teams and built this health check for this API, and it was connecting to the database, a file share. It was doing quite a few things, and he was so happy because he's like, look, in this health check, I'm making sure it can do this and that. I'm checking everything. Like, this is the best health check ever. And it was. It really did check everything. Fast forward, that got to production, bolted on monitoring. It brought the system to its knees. What we didn't realize is the monitoring tool was just beating that health check like multiple times a second. And when you're checking all those things, of course, it was causing a bottleneck. So bend it. Better. So, yeah, much better. Okay. So be careful with your health checks, for sure. Message queues. Make sure you monitor your message queues. And this is depth, dead letter queues. We'll get into that a little bit more later. Error logs. You've got error logs. You just built this fancy, flashy, error log system. Set thresholds. Okay, you're going to get logs. I promise. You're going to get errors. That's just the reality of the system. It's going to be a problem. But do you want to be alerted at 2 in the morning if you get 5 errors? Meh. 10 errors? 100 errors? Okay, now you're talking. Maybe you've got an issue here. So you need to figure out what that threshold is and only alert out when you get that threshold. That way, if you're not wasting your time, you've probably got an issue if you're getting a large number of errors in a short amount of time. Okay, those are obvious, Heath. I get that. That's fine. But what about the other things? So monitor the expected. And what I mean here, you've got a batch process. This batch process runs, say, every 5 minutes. It wakes up, connects and does some things, and then goes to sleep and waits 5 more minutes. Okay, that's the expected. Monitor that. Track that somewhere so that when you have a monitor on that, you say, okay, I expect this thing to run every 5 minutes. Did it run? It's been 10 minutes. It hasn't run. I bet that job's hung. I bet it's stuck. Something's going on with that. So this is monitoring the expected. If you know something's going to happen, put monitoring around it. And last one here is my favorite. We didn't actually do this with this system, but for another company I worked for, we did this, and it worked really well. So take your, we talked about those business transactions, cross-cutting, multiple microservices, inject synthetic messages in there. So fulfillment request, we've got a message that comes in that says, go pick, pack, and ship this product. Okay, well, inject a fake one in there and let it go through that whole process. Well, why would I do that, Heath? Because then you can do something like this. We called this the pulse, for lack of a better term, that's what the tool got named, but it allows you to put a time on that. So you say, okay, normally it takes, in this case, what, 8 seconds, 5 seconds to go through this series of you know, this business transaction to go through these microservices? Okay, that's cool. I've got a baseline. Is that good or bad? I don't care, doesn't matter. Yeah, I've got a baseline. Keep an eye on that. So if you see that time going up, systems don't normally just fail. It's not an on-off, okay, this, obviously the system's down here. No, they never happen like that in production. You know that. It happens where you've got some sort of bottleneck and things just start to slow down. You're like, what's slow? What's going on? This sheds light on that. So when these things start to slow down, set your threshold. You know, if it's taking 30 seconds when it normally takes 5, you probably got an issue. So we did this with synthetic messages, and it worked really well. It also allowed the business to put SLAs to track IT, of course. So there's that part of it as well. Okay, eventual consistency. So let's dive into this. This is the second part of the talk. And what exactly does eventual mean? So I've got a microservice here, an order creation. Fulfillment request comes in, goes into this message queue, maybe sub-services, but eventually this fulfillment request is going to show up as an order in a transactional database so that I can do an order search. Keyword is eventually. And whenever you tell someone eventually, they're like, I don't have time to wait on this, no, eventually it's typically like seconds, right? If you've got your system up and running and you're pulling code or pulling a message off a queue and processing it, we're talking seconds. But it's not instant. And why do we do this? To eliminate coordinated transactions, which we'll get into a little bit more detail. But you're like, Heath, no, I don't need to do this. I'm going to build my microservice, and I want to get my data now. So you do. So you build out this fancy, nice business transaction, and you got message coming in, and you're calling microservice after microservice after microservice. That's a lot of call chains. What happens if one of them goes down? You've just broken the entire business transaction. And I promise you, it will definitely go down. War wounds, battle wounds, it's happened. So how do we fix this? How do we add in the eventual consistency to this picture? What we do is add in a message queue. So in this case, we've got the message that comes in, the first microservice, very basic, doesn't do much, queues that message, and then we have the other microservices listening on that queue, pub sub. It changes your architecture substantially. It changes your mindset substantially. But it works. Okay, another way to do this, it's not separate. Combine the ideas here is, I think, has everyone heard of CQRS? Is that a lot of hands here? Yeah, very old term. It's been around forever. So command, query, responsibility, segregation. The idea here is separate your writes from your reads, and think about your writes. If you're on Amazon, e-com website, placing an order, do you expect when you get to the cart and you get that one, click now, buy now, whatever that button is, that by the time the graphic, the animation on that button, that it pops up, you've got an email with your order, right? The order's processed, it's already inserted, you got that email, success. You don't expect that, right? You just know, right? There's something's going to happen behind the scenes, so you're trained for writes that they're going to, if it's impacting the system, that it's a little times okay. So maybe in a couple minutes I'll get that email saying, hey, we got your order, we're processing it. Whereas reads, speed is king. If you're on, again, back to the Amazon example, and you're searching for products, if that page delays 2 seconds, you're out of there. Doesn't seem like a long time, but try it. Try 3 seconds. Just put a pause in there. You can go into Chrome DevTools and put a pause in there, a delay, network delay. 3 seconds is an eternity, and you jump ship. So separating those things out is extremely important for this architecture. And how do we do it? I told you I was going to come back to this Elasticsearch. I'm really giddy about this. This is a good takeaway here. If you're not using Elasticsearch or done any research into it, definitely do it. Highly recommend it. Not the same exact system here because I already told you it's one monolithic database, but so hang with me here. You got multiple databases here, and you need to synchronize that data into Elasticsearch so that you can, well, do search things on it. So we used CDC, Change Data Capture, built into SQL Server, monitor for changes. And you're not going to monitor every single table, every single column. You'll have certain tables, certain columns you want to monitor. Those changes trigger updates. You push those updates into Elasticsearch, and now you've got a JSON searchable representation of your data. Ready built, ready to go, formatted for a couple things. Either a dedicated search microservice, which is full text search, or you can do faceted search, which is just basically searching by attributes. Or, better yet, build a BFF. Anyone heard of that term? Yeah, it's a real thing, BFF. Back end for the front end. And we've done this. And what happens when you do that, so you've got your data for a front-end application, purpose-built, maybe it's a mobile application, it's extremely fast, I promise you, very fast. Why? Because you don't have to do this crazy query that joins multiple tables. You've got the data already formatted in a format, in a JSON format that's going to return for your REST API that's really quick. So give it a shot, try it. I've been a huge fan of it. All right, let's talk about back to this, I call this queue-based load leveling. But remember this picture? This was like the second slide or maybe the third slide where we've got all these 1,200 brick and mortar stores, 35 or 13, 15 e-com websites. It's a lot, okay? So of course, when you're designing this system out as an architect, you go ask the business, okay, really, how many orders, how many requests are coming in? And they say, okay, well, about 12 a store. And so we calculated that out and said, okay, about 100,000. And what really happened? 500,000 plus. And I say plus because some of that was like, boom, all at once. Here's all your orders. Congratulations, go. And you know what happened? We turned it on. All the orders came in, and the system crawled to its knees and stopped, and we threw it all away and rewrote it. No, that really didn't happen. What happened was we planned for this, and you should too if you're doing a system like this. So separate out your extremely fast, few moving parts from your heavy, slower moving parts. You have to find where that seam is, the architectural seam in your architecture of your code. Find where that is. For us, it was fulfillment request. We've got these orders coming in from partners, from stores, from everywhere. Everything's being aggregated across this one fulfillment API. Fine, that's the fast-moving part. So what do we tell partners? Give me a basic JSON payload of what a fulfillment request looks like. I don't need the order details. Some of these orders are for store replenishments. So a store is ordering hundreds of products all at one time to replenish their stock there. Don't give me that. Just give me an extremely basic, lightweight JSON. Take that. Through our API request, do basic validation. We're not talking anything heavy. And then queue it up. You're done. Problem solved. That's fast. And working with a lot of other architects at business, partner businesses, and they're, how quick is this going to be? Because I'm designing my system here, and it needs to be fast. Hey, pal, it's like 15 milliseconds. You're good. Okay, that's the fast-moving parts. You still need to do the other parts, right? You still need to go back, get those order details, go through all the business transactions, eventually get that into a searchable database. You do that here with the queue. So you've got a queue here. Now we've got bursty traffic. So you've got a million orders just dropped on you all at once. It's just in the queue, just sitting there. No harm, no foul. Let's ramp these up. So I've got fulfillment handler services. I can ramp up many of those. And if you're doing this on Azure, like most of real people building this stuff, or any sort of cloud environment, this is all automatic. So these ramp up and process and do all the heavy work. So this is a technique that really saved us because that's exactly what happened. Way more orders than we expected, and the system chummed along with no issues. When you're building this out, so we already mentioned having a queue is an extremely important part of your architecture here, is define your domain events. And there's lots of exercises you can do. I like to follow a DDD approach where I'll get IT in the room, get the business in the room, and we'll do something called event storming. I don't know if anyone has done an event storming exercise before. It's very simple. You ask, what's some of the interesting events that's going to happen in your system here? We're not talking code, architecture. Just tell me about your business. for this domain, talk about some of the interesting things that happen. You'll get a big list of those, I promise you. Put them in stickies, put them on a white note or on a whiteboard, and then figure out what triggers that event and what are the outcomes. Because you'll get some interesting answers where, oh yeah, this event comes up and Bill out in shipping needs to know about this because he needs to go manually enter it into this other system. So it also acts as a requirement gathering mechanism. But come up with these events and model those events, use the same names, whatever the business is using, you use as well, and build domain events that trigger off that. So this is essentially would be your topics and message queues. You can see some of the examples we have there: order created, verified, order shipped, all interesting parts of the system here. Okay, self-healing. So we've talked about microservices a little bit. We talked about logging. We got through there. Okay, now Heath, I get it. Queues are important. I need to do that. Self-healing is all about, okay, you've followed these patterns. You've got up to this point is, I've got a system and it's going to have issues, I promise you. There's going to be network connections that go down. There's going to be edge cases, likely edge cases that you didn't expect when you built the code because you can't know everything all up front. So you're going to have problems. You want those to self-heal. Would it be nice if maybe you had to get up at 3 in the morning, you fixed the thing that was broke, but now your message queues are just loaded. You've got all kinds of failed messages in these queues. What if they just automatically just reprocess themselves? That's all about self-healing. That's what we try to design into the system. So we've got several patterns here that we can leverage that's at our disposal. Some of these very basic. So automated retries with backoff. This is what we built. Keep in mind, we used RabbitMQ as our queuing mechanism. Doesn't need to be RabbitMQ, but some of the terminology here is based off Rabbit. So you get an initial service request that comes in. That the handler, the fulfillment request that comes in, and then you got a handler that wakes up. So it says, okay, I got a message in that queue. Let's pull it off the queue, and we're going to make a downstream API call. Okay, that call fails. Could be a number of reasons. It could be the network. It could be that the system's down. It could be just you got a bad data in that message, but it failed for whatever reason. Take that message and put it into another queue. Call it a retry queue. That's exactly what we called it. And in that retry queue, do a couple things. Increment the retry count. So how many times has this been in that retry queue? In this case, the first time is going to be 1. And then take that number and set a TTL, which is the time to live, and multiply it by your recount number. So 30 seconds is what we chose here. So we've got this message in a retry queue. So first time it's being retried for 30 seconds. Rabbit automatically handles that TTL, and once the TTL expires, re-enqueues it back into your primary queue. So you're using queues as a retry mechanism. And then the process repeats. Now that it's here, the handler picks it up. Maybe it failed a second time, so it's going to be the second time in the queue, and now it's 30 or 60 seconds, 30 times 2. So you're automatically building backoffs into your system here. So this gives us backoff or retries with backoff. What happens after 3 tries? Obvious question. So you've got this all automated. Messages coming in. We talked about that based on TTL. After 3 tries, it's got to go somewhere. So we call this a dead letter queue. Yet another queue that makes up this series of queues for this business transaction. And dead letter queues are built for one purpose, should be built for one purpose, poison messages. So these are messages that come in, whether it's JSON, EDI file, doesn't matter what it is, that, again, it's either an edge case in your code that you didn't consider, or maybe a malformed file that came in, had an extra character, because we've all run into that. Like, I didn't expect a special character at the end of that. Come on, silly. But those go to the dead letter queue. And an important part about the dead letter queue, you'll see here, is dead letter queues require humans. They require someone to go review those poison messages, understand what the issue is, whether it's a code issue or whether it's a problem with the message itself, and manual updates need to either be made to that message or the code. Maybe there is a edge case that you need to redeploy a piece of your architecture. And then eventually, you'll get it to where it's in a good state, and you can boop, move that message over. So we got a dead letter queue, and we're creating messages in there. They're supposed to be poison messages. Any thoughts on what else can get into this dead letter queue? what about if a system's down? So you don't have a edge case or a poison message. You actually have legit something is down. That black and white case that I said never happens, imagine it happened. So you've got a system that's down. This dead letter queue is going to start filling up fast. And this is not just poison messages. You're going to get messages in here that would have legit passed or gone through the system, but are ending up here because they got nowhere else to go. And I already mentioned this is manual, requires humans, so that's not fun when you've got all these things built in. We already said this is all about self-healing. We don't want to have to deal with this. We need to make this automated to catch that scenario so that when things get back up and running, when you make that 3 in the morning call and get things back up and started, it just restarts itself. Real quick before I tell you the answer, I like this because how do humans do retries? I told you I'd come back to this. We built it in. So that screen where you go through, you're up at 3 in the morning, you got issues, you got a number here, you do a search, it comes up there, and you got the issue fixed, you can retry onesie-twosie, that's okay. Or, I love the name of this, like the developers that wrote this, shovel. So basically shovel from one queue and toss it over into the other queue. Awesome name. A+ for names. I'm terrible at naming things. I don't know if you guys are good at naming things, but I enjoyed that part. So then we get to, so back on track, back to the story here. How do I avoid this? What do I do? So we use something called the circuit breaker pattern. And the same idea, we've got our message queue, and we've got our fulfillment handler microservice, and we monitor that call. So put a monitor on it. You can monitor the queue itself, or better yet, use a tool like Poly that has this built-in automatically designed for this. Set a policy on that, and track that to see, okay, is that failing? It's going to fail, I promise you. So this gets back into that, well, how many failures are a problem? So you keep track on this, and 2 things you need to consider here. Lots of errors, short amount of time. So lots of errors could mean 100, it could mean 1,000, it could be 1,000,000, depending on how big your size of your system is. And a short amount of time could be a minute, 2 minutes, 10 minutes. You need to find those parameters. So you monitor that, and now you're getting lots of errors, short amount of time. The circuit breaker, which is currently closed, closed means it's flowing, right? More like an electrical circuit breaker. It's closed, it's flowing, opens up. So now you've got that thing open. You've got basically a halt comes up to your microservice handler. So don't even try to make a downstream call. The system is down, the network's down. Something about this is not quite right. Don't even try because you're only going to cause more pain. So don't create more dead letter messages. Stop. You'll have a few. Based on your lots of errors and short amount of time, whatever that threshold is, you're going to have a few, but this stops. Okay, so I've got the circuit breaker open. I go in 3 in the morning, get the things up and running. Now I still have all these messages that are setting in the transactional queue. How do I start that back up? Well, circuit breakers have something called half open. And again, this is all built into the Poly as a tool we used here, but wake up, try a message. Just take one through, not a 10, not 20, just send one through, see what happens. Did that one pass? Okay, that one passed. Try another one. So you can set these policies so that once you get a few messages through, the circuit breaker is like, okay, I think we're good now. We're just going to open up the floodgates and start processing and loading up more instances of this microservice handler, fulfillment handler, and really go after it. So this is the self-healing part, where you're going to have a few of those poison messages you need to fix, but not many. You've stopped it from flooding. And after you get the system fixed, it just self-heals. It just starts flowing again. A little bit of magic. Okay, idempotent services. So everyone heard of idempotency? Yeah, another very common term here. So I've got an API, and how it pertains to microservices, I've got an API, and I've got a message, whether it's JSON, EDF out, doesn't matter what it is. If I send an exact copy of that message twice, when it goes through, it processes, I get a tuner response, we're happy, we're good to go. I send it again, I better not have side effects. So that's idempotency, is when you retry that same message, you detect that, you catch that, and you don't have side effects. And why do we do this? Because I'll get up here and I will guarantee, I don't know how it happens. The bits align or a solar flare comes in and causes some of this to happen, but you're going to get identical message requests. It just happens. You're going to get delayed times. They're going to come out of order. If you write any code that looks at a date timestamp, don't ever do that. There's the time drift issue, so with any distributed system, never use time as any sort of guarantee, because it may not be, maybe in the future or in the past. And they're going to show up out of order, I promise you. So it makes this hard, doesn't it? I mean, if you know these are all going to happen, how do you build a system around this to be able to handle that? And this is where eventual consistency comes at a price, right? If we were doing all this in one single monolith application, one process, none of this really matters that much, but here's where it comes at a substantial price and a different thinking on how you're building your microservices architecture. So what do I recommend? Well, code with idempotency in mind. And what do I mean by that is when you create tests, now these are maybe more integration tests and less unit tests, but you might be able to unit test this, is test it with a duplicate message. Just send it through and make sure your code handles that. Make it a PR checklist item that you're double checking these things and protect your microservice from any edge case. I do think that almost all issues, from my experience, the issues I see with microservices are not because things are down, not because things are slowing down, not because you get special characters in the message. That does happen. It's all about edge cases. You know, you can't catch everything in the requirement gathering phase. At least I've never seen it. So these things creep up, they bite you. But if you know this ahead of time and build this into your process, your development process as well as your code, you're expecting them. And you'll be able to handle them with grace, find where that edge case is. Hopefully you've built your microservices architecture so that it's a small piece of code, change that, redeploy, self-healing kicks in, and you're back up and running. Case in point, humans make mistakes. We all do. I made lots of mistakes. We had this. So a development database and a production database. Seems normal, right? Maybe you had a test database in there as well, but don't do this. Really, don't do that. Because, no kidding, this actually happened, and it wasn't our code, wasn't us. It was a partner, trading partner, where a development database got restored to production. So the next morning, guess what? When all these orders came flowing in, we got last week's orders. And the week before that, probably 2 years of orders. It all got dumped in here. And if we didn't have this idempotency built into our system, guess what? We may not have caught it on time. These orders are dumped at like 2 in the morning, 3 in the morning when the batch runs on their side. We may have shipped out product to customers that were shipped out a year ago. So account for this in your system, make it idempotent, double check these things, and reject it, which is exactly what our system did. We handled this like a beast. Came in, nothing got sent out. They were all sitting there, aired out messages, likely in a dead letter queue, and we're able to find out the issue from the partner who then fessed up to it later that morning. Okay, well, how do I do this then? So if I want to build a API endpoint and I need to go through and validate this is not the same message, here's one approach. This approach worked for us. It's not easy, and you got to do some of this manually in code, and it's going to make your API, which is probably beautiful, look a little messy at times, but it's what you got to do. And I wouldn't apply this pattern to every piece of code, only in those cases where it's make or break. The example I just gave there with the inbound fulfillment handler. So let's walk through this. Break up your code into transactions, into checkpoints. So I've got a request that comes in, it's a fulfillment request, and I need to do some validation, basic validation. There are 0 side effects on validation, other than a query on the table. Right? I need to run a few queries, so there's a compute that goes along with that, and that's fine. But since there's no side effects, let's just do it every time. Don't complicate the code. So we do it. So that's not a checkpoint. We go through, run that read operation, and we're done. We get to the very first thing that actually has, so step 3 here, has some sort of side effect. I'm creating an order header. Okay? Well, what's the checkpoint? In this case, it's a very easy contrived example, is I've got an external number from the partner, order number, check it. Is it in that header table? Was it ever in that header table? Is it in an archive table if you're doing archival strategies? However you check, has this been done before? Okay, if it's been done, don't do it. but also don't stop. So I've seen people do this type of architecture, and at that point, just kick out and say, "Bloop, I'm done." That's bad, because maybe, just maybe, this is not a message from last year. This is a real message that you had a downstream system that, this order table had an issue, and you couldn't actually insert that order table. So it's a legit thing. Do it, or don't do it, skip it, and then move on. So the next thing we get here for is get stock levels. So this is, again, no side effects. Always do this, and extremely important to do. Step 5, again, checkpoint 2. So checkpoint 2 is maybe you were able to create the order header the last time this message came through, but your edge case in your code, the bug that was just deployed yesterday that you didn't check for, or whoops, was here and not there. So you've already done this, you skipped it, now you get here, back to that self-healing. So once we get to this point, go ahead and do this. Also check to see if there's a checkpoint 3 here, and continue the process. So that's how we approach this problem. I promise you it does make the code look ugly, but it gives you a lot of safeguards here. This is essentially whitelisting your code. You know how it's supposed to operate. You're only allowing the happy cases to flow through. Okay. We've talked about all these patterns. We've talked about all these things. Here's an interesting use case, is partition your business transactions. So I've got a business transaction we've already defined. Maybe even I've got synthetic messages going through so I can see the pulse, plot all that. You've ticked all the boxes. You're happy about this. And you think it's perfect. Partitioning your business transactions is important. And what I mean by that is these are all instances. This is same code, not a different version of the code, not a different part. But when they start up, you can use command line, config file, whatever you want to use. They pull in some sort of partition key. For our case, we use business partner. It seemed natural. And pull that up and only process messages for that given business partner. So that's your partition key. And why did you do that? Well, a couple reasons. One, it creates a nice, natural seam for developers. Okay, if I need to get a new trading partner in here, it's just, here's what I do. I just create one of these, give it a partition key. There's that. More importantly, remember that example where you've got a finite number of resources that are coming in. So you can handle 1 million messages in that queue, but say you get one business partner that goes a little awry, and their messages come in, and they go through this thing. You've got circuit breakers in there, and you detect an edge case, so your circuit breaker opens, as it's designed to do. One partner opened your circuit breaker. The other partners were flowing fine, so it's something in their message that's now breaking down or tearing down your entire system. So by using a partition key, what that allows you to do is cordon off one single, so it's a bulkhead pattern, a way to cordon off one single partner. Your circuit breaker will pop just for that one partner, or you can completely turn off that interface for that partner so that your other handlers are flowing through with no issues at all. Okay. Last part here, expect the unexpected, and just a few thoughts. I don't have all the answers here because it's, how could you expect the unexpected? But a couple things is, again, unless you have like infinite money on your teams, infinite dollars, you're not going to catch every single thing. Now, if you're creating airline avionics systems, I used to work in avionics, and yeah, they spend a lot of money on that stuff. The reason why that piece of equipment is like millions and millions of dollars is their test cases are crazy. But for most of us humans here working on business applications, you're not going to be able to do it. So defensive coding is important. And don't make assumptions, whitelist. Whether you're doing checklist techniques that I covered earlier, or just anything that doesn't match, kick out for whatever reason. So be very defensive with your code. And then if you've got this all right, and you do have an edge case, like I mentioned before, and it's a microservices architecture, it's a quick fix. Make your minor fix, figure out where it is, blame the developer, of course, harass them probably a little bit, but deploy and you're good to go. Okay, and lastly here, DevOps culture. 2-3 years ago, this is probably an important point. Now I hope we're all like DevOps culture. Everything's automated. All build pipelines are there. I hope every one of you are building automation into your everyday life, but incorporate all these edge cases back into your sprint cycles. So it doesn't go from, I found a bug, it's a problem that's going to impact us. I was expecting that bug. I have bandwidth into my DevOps lifecycle where I can take that bug, redeploy it, get it out into production in a relatively short amount of time. So it should be a planned item that's in your backlog and a planned capacity in your sprints for a large system. Okay, and be prepared, be flexible, do these. If you're not doing these already, test for bursty traffic because what you hear, the example I gave with the number of orders coming down from the stores, test this out. So hammer it. Go through and see how your system would handle with twice or thrice or 4 times the number of messages. Those partition keys, you may not get it right the first time. Business partner worked well for this use case, but say you had business unit and it was an internal application and you've got one business unit that's based out of New York and another one that's based out of a really small city in Ohio somewhere. So probably not a good partition key. You may want to spread that out or repartition based on actual mileage and order that's come through. So, and in general, stay agile. So that is all I have. I hope you found this useful. That is my LinkedIn profile, so connect. And again, if you want a free t-shirt or you want to hear about CGI, come out to the booth here. I'll be here all day. And we're giving away a Thor hammer. If you haven't seen, we have a giant Thor hammer. And if you go up to it and tell it, I am Thor, it lights up. I'm not kidding, it really does. So go up and try it, I want to see you. We'll take videos of it. All right, appreciate it. If you have questions, put it on Discord. And I'll try to answer any questions there. And thank you, everyone.